So we will now talk about databases into the cloud, and I'll keep the conversation focused again on basics of the databases, and then we will go into the details of it, how it works. So we have SQL and NoSQL databases. This is a very common thing. A lot of people have a complication in understanding it. So I'll try to cover SQL and NoSQL databases. We sometimes refer them as relational or non-relational. So you decide whatever you want to call it. But the idea is that we want to store data in a different format. Now let me use some analogies again to explain you the concept associated with that. And probably some of you would relate to me now when I'm sharing this. Let's cook a banana bread, right? Obviously, it's just Sunday coming up tomorrow, and this is my plan. I'm not sure if I follow the same recipe, but the idea I am trying to convey here. If I have a recipe book, and if I'm trying to bake something as the banana bread, what I would do, I would go to the page number of that banana bread and I would get all the details there. I don't have to keep on looking from page 1 to page 5 and then 5 to 12 or 15 or 17. What I have here in my front of me is a document, and all my information, whatever I need, is there into this document itself, right? So that is what is information presented into one single flat structure, no relationship from this table to that table or from this page to that page. That is my one single page, and this is what we refer in any technical word. This is a document. When we say document, it doesn't mean Microsoft Word document. A document is a place, maybe into a JSON format, we would have our data being stored here, and that is all information about making up the banana bread, right? This is your non-relational database. Everything in one place. You go ahead, get the document, go inside it, and figure out how to find out the information you need. All right. Now let's focus on the second aspect, non-relational. See this ingredient list? Now I don't expect that I have all of these things in my home as of now. So what I have to do in this case, I have to go to a supermarket. And on that supermarket, I would have a shopping cart and I would keep on filling that stuff, whatever I need, into my shopping cart. That is your relational database. You have different tables, table 1, table 2, table 3. Maybe it has drinks, it has fruits, it has cheese, crisp, and that's how you would be bringing multiple records into your shopping cart by writing a SQL query. And the SQL query would go ahead to different table, get the required information whatever you need, and bring it to you as output. So that's what is a relational database, in which there are different tables, and you run query which goes across tables and deliver you the result on that. So I hope this basic information is clear. Then in relational databases, you would have different table. Collectively, they will give you a data. And in your tradition, in your NoSQL database or non-relational, probably there would be one single flat document in which your data would be stored and delivered back to you. So I hope this thing is clear to you and you have understanding on this concept. Let's now go ahead and talk about the not then other technical thing associated on that, right? So yeah, hopefully this makes your life easier, right? So when you will now go to grocery store, you would see it in a different manner and you would be having your cart, which will be your SQL query, and you would keep on adding stuff inside it. So hope you are following along. All right, let's move forward now. In a SQL and NoSQL database, SQL databases store data into rows and columns. That is a common way, whereas NoSQL have different ways of storing data, which is your document, wide column graph. What I have explained right now is rows and column. That is your table coming from different places. The data is coming up, and in a document, your data would be stored in this format. Like I have ID1, full name, last name, and year, and all. That's how these things would be working. Right. Now, what I have here, another concept we have written, NoSQL, which is optimized for performance, and SQL is optimized for storage. That is also a key factor on how the data is stored inside these locations. Let's talk about it. This picture I have shared in my previous session also. What is happening here? This is a 5 MB hard drive being moved from IBM capacity, IBM facility. This one is called portable 5 MB hard drive. Is it portable? Yes, it is. If you have 5 men and a one van, then it is portable. So that is how transportation of hard disk used to happen. Point I'm trying to clarify here is that hard disk initially was very, very costly. So any solution which were designed, like relational databases came into picture in 1970s, and that time they wanted to keep storage cost as much as low as possible. But if you look at today, this is a small fingertip like 1 TB storage device you could get, and that is much, much cheaper now. So storage is not very costly now, and that's why our requests are requiring more performance. So in earlier days, storage was very costly, computing was not, and that's why we had designed everything to store our data in a storage efficient fashion. But now with web scale application like Facebook, Amazon, Google, millions of users are accessing it, and we want to ensure that everyone get the same performance provided how much data is there or how much data you want to keep inside. So that will be always there. We want to have say best performance coming up, so compute is our priority and not the storage now, right? So this is other format which no SQL data can store data in. So it can have a key value pair, right? So I'm using username, Ashish, password 1234, city, London, graph. This is another database like social networking. A is friend with B, B is friend with C. Let's recommend C and A to be friend also, or a wide column database or a document. So no SQL, they are storing data in a way which will give them the best performance rather than focusing on the storage space. So that is another difference between SQL and no SQL databases, right? Next one is schema. SQL databases requires you to have a fixed schema. You have to be very thorough with your schema design on very first time, like what keys you want to include, what values you want to have, what would be the table items you want to keep, and that all information would be required when you are using the schema which is fixed. On the other hand, here no SQL, it is a dynamic schema. So I have items here, and you could see one item may have more values inside or attributes inside than the other, and it is completely acceptable, completely flexible that you may utilize different type of things there. So NoSQL allows you to have that kind of flexibility, right? So that is your NoSQL, right? Flexible. Now schema fixed. I take another example here. When you travel to air, so airline would give you a size for your luggage, right? That your luggage cannot go beyond that size. So when you are carrying a cabin luggage, you cannot go beyond that particular cabin size. That is your fixed schema, right? But when I am sending something through a big courier company, then I may send guitar maybe, right? So that is possible. I could package it into it and send it. So that is my dynamic. They accept different package sizes, but my airline accept a fixed size for my cabin luggage. So that is my fixed schema and dynamic schema, right? Now, how to query these data? In a standard way, we use SQL query like I'm saying select star from music where artist is Elvis, and that's how we are able to get the Elvis information, all the music created by Elvis. On the other hand, here we are saying, okay, I want to talk to a table called music, and I want to search there or an expression where the artist name is Elvis. So I would get the similar data available, but the query format will be not SQL, and that's why we sometimes refer it as a no SQL. But this line is becoming blur and blur day by day, because now we have databases which are physically no SQL or technically no SQL, but they still allow you to write SQL query. An interpreter in between will translate it into a different format, get your result, and you will feel I have just written a SQL on an SQL database. So that is also there. We could utilize it. Next is scaling. So scaling is vertical in SQL databases. It's a single node, and then I would add bigger node. I would throw more CPU and memory to solve the problem, and I will keep on making that node bigger and bigger. But I would soon hit a limit that how much physically I can put it into one node, because there is a limit in terms of physics, how much power I could put to one node, cooling I can provide, physical size or dimension of it. So I would soon hit a limit in terms of vertical scaling, as we see here, whereas your NoSQL databases are using horizontal scaling. So I'm using node 1, I add another node, I node another node, or sometime in some databases this is referred as partitions. So they would keep on adding partitions and keep on adding as much data as you want. So that is called my horizontal scaling. So I hope this thing is clear. Now, another good thing which are about SQL databases that they support transaction. Transaction is basically when you are doing an activity which has multiple phases inside. I call that transaction. So let's say I have to transfer money from my account A to someone's account B. So in that case, that money has to be deducted from my account. It will go to my bank's account. That bank will transfer to the destination bank. So now it will remove from their account, will go to this bank account. This bank will check this account, remove from their account and transfer here. And when this happened, this whole process is a transaction. Right. Now, in this whole process, if any of the phase fails, then your transaction would not be carried out. Like you're buying something on Amazon.com. You bought that product, so your credit card should pass. Amazon should have a delivery location, which is your destination you selected. Amazon should have a option to deliver on the time frame you selected. You want next day delivery, but what if your location is not supporting next day delivery? So that transaction won't happen till every phase of the transaction is complete. So that we need here, that is sometimes is referred as ACID transaction. Your transactions are atomic, consistent, isolated, and durable. So we support these transactions on that. No SQL. Again, as I'm saying, that line is becoming blurred day by day. Some databases, they are no SQL, but they still support transaction. So support of this transaction varies. Or just to create a similar terminology in terms of ACID, they call it base. So these NoSQL databases support concept of basic availability. They have data into soft state and they may have eventual consistency. So that is called acid and base, the chemistry thing. Acid is opposite of base is opposite of acid. Similar stuff we are using here into this particular language. So I hope this differentiation is clear. And when we will talk about DynamoDB, we will talk more on these type of eventual consistency or soft state and basic availability. All right. So I hope this thing is clear. And now we would start focusing on Amazon solution, which allowed to use. NoSQL mostly follow CAP. Yeah, I agree on that, Samuel. So CAP is a theorem which you could check on internet, and NoSQL would be mostly following the CAP theorem. Let's talk about Amazon's RDS service. Let's see why we need a service like that, how we would be utilizing Amazon RDS, relational database service. Right. Let's say I want to run a database, and that database I want to run on my on-prem environment. All right. So I on-prem, I have to take care of rack space. I have to have physical space to host my server. I would have cooling and ventilation done. I would deploy a physical server, have operating system installed, patch it, database software installed, database patching done, then backups configured, high availability configured, and scaling configured. I am doing all these things. So that is a lot of stuff which I have to do. What if I want to use cloud? One option for me is I could go ahead and say I would take a EC2 machine, so that all these things of operating system installation, physical space, its cooling and ventilation, rack space is all done by AWS. And once I have this EC2 machine, on top of it, I would then install my own database. But in this case, I am still worried about patching of operating system, high availability, scaling, and all. So what you see here, these are your unmanaged databases. You manage them, unmanaged. Amazon RDS is a managed database service. Amazon RDS says, all right, we will help you in achieving whatever you need. And these activity where you had to spend a lot of time, like scaling, high availability, backup, patching, they will all become just a checkbox activity. So you select on a database, I want patching to be done, we will take care. I want scaling to happen, I want a bigger instance, we will install that for you. I want it to have a highly available architecture, we will take care of that. So that is called my managed database, which is Amazon RDS. And through this managed RDS service, I could deploy different databases. I will talk about them. And that would give me a way to deliver my application the required performance and capacity without worrying about the back end stuff of high availability or operating system or patches. This one is referred as my managed database. All right. Any questions, any doubts, any confusion so far? Anyone who is not clear with managed databases? Let's now start focusing on Amazon RDS. So RDS gives you choice of different database engine. MySQL, Postgres, MariaDB, all my open source. MySQL, Oracle, enterprise grade, and Amazon's own engine, which is Amazon Aurora. So best would be I show this thing into console. So I could go ahead and maybe this is my AWS console. I am interested in RDS. RDS is a regional service, so I would select a region, and in that region, I would say I want to deploy a RDS database. There is a soft limit enforced on every AWS account. In a region, you can have up to 40 databases created. If you need more than that, ask AWS to increase your limit. But if you see here, you have 40 databases you could create up to. So I am interested to create a database. You have to select what engine you want for your database. So when I'm say I want to create a database, it would ask me some basic question. Let me go through a wizard, prepare some answer, and then let my database be created based on the configuration we have selected. So I could go with standard create, in which it will ask me some basic question. I am not interested to answer that many question. Easy create. Let's keep standard, and we will explore the options available. So I have 6 options to select from. 6 type of engine I could select for my RDS database. Amazon Aurora, both option MySQL compatible and Postgres compatible. I may have MySQL, MariaDB, Postgres SQL, and Oracle, which I could use, or even I could have Microsoft SQL Server. So Aurora comes in 2 flavor. I'll talk about them, and then I have MySQL, Oracle, Postgres, and SQL Server to get started. Whatever you select, we will give you further options there. So you want to have a Microsoft SQL Server, all right. We would give you option to select different editions of that SQL Server, which version of SQL Server you are actually looking for, any specific setting, like if you want to have any database instance created, then credentials configured on that, then instance size. Basically, behind the scene, it is still a EC2 machine, but that would be managed and operated by AWS for you. So you could have selected different options available for your database which you want to deploy here. Right. You will provide some storage. We support auto scaling of storage, so your storage can grow as you want. We will start initially with 20 GB, but we will let it grow up to 1000 GB if you need to. And it is a kind of EC2 instance, so it would require network connectivity. I could have dual stack. I could run it as a compute resource connectivity also on that, put it inside of VPC, go ahead with some additional setting about security groups, proxy services, and done. And I could also select some of the maintenance options here, right? Database port, which port I want to change. I want to have a SQL Server Windows authentication done. I want to collect data from it for monitoring. Maybe I want to perform a parameter which is my customization done to it, type very specific time zone I want to use, when I would perform backup. Do I want to copy tags to the snapshot? So these are all the basic stuff. And see this, we could even say enable auto minor version upgrade. So AWS would take care of upgrade for me. I could select a maintenance window, and on that time my patches would be applied on my environment based on my requirements. So that is a good way to just have a database, and once I click on create, it would take care of the setting I specified, and my machine would be getting the database instance for me. Now, one thing to be aware here, what you are creating a database instance. Let me draw that. So you are creating here a database instance. That database instance is basically made up of the server you need. This is a virtual server behind the scene given to you. And on that virtual server, obviously you have your operating system, and on that operating system, your database software is also installed. So once this instance is ready, I would use some tool which I am familiar with, like SQL Workbench or SQL Management Studio or Oracle's tool. And through that, I would connect to this database instance. And once this I connect to it, I would then create databases on top of it. So instance is the server of database. And on that instance, I could have multiple databases created. Shouldn't be a problem at all. And then I would be creating tables to store my data on. That's how your architecture would look like. I hope everyone is clear and following along that what we do when we say I am creating a database instance, I'm setting up the backend, and on that I would have my databases created. So it depends on, like, some engine would allow you to have a default database created, like Oracle would have something default, MySQL would have something default, and depending on the use case, you would be selecting what type of requirements you have, and your database would get ready for you. All right, very easy, not a complicated thing. So I hope everyone is following along. So we have choice of different database engine to choose from. We support high availability and read replica. I'll explain them in a minute that what is my high availability and what is read replica. We will select all these things. We will talk about that. All right. All right. Now, what else? You could create snapshot which can be copied across region. So maybe if I want to have a backup of this database created somewhere, I could go ahead and put it into a snapshot. Snapshot, then I can go ahead and put it into a different location, different region, and restore my database from there. Should not be a problem at all. You can migrate database using DMS, a tool we provide by which you could move your on-prem databases or cloud databases to a managed service by AWS. No problem at all on that. And when it comes to pricing of Amazon RDS, the pricing is on demand, like how many time you keep launching that instance, you will pay for that. And if you have a consistent usage of a database, you would probably have a reserved instance created on that. So you would create a database and have reservation applied on that, so you would be able to get a cost on that. Data query only. As there is estimated cost mentioned, can we also create a serverless DB where it will be priced based on data query only? It can be done, Samuel, but that is only for Amazon Aurora serverless. So that will be Amazon Aurora serverless, where you will be paying by the node hours of Amazon Aurora. That is called Aurora capacity unit, which is made up of some compute and some scan capacity. So yes, that is possible. You could utilize Aurora's function, which is called Aurora serverless, but not possible with standard MySQL or Microsoft SQL or Oracle databases. They are not operating in a serverless fashion. So on those databases, you pay for the database instance. Right. So I deployed a database instance which has 4 CPU in that and has 16 GB of RAM. Even if I am using 1% of capacity, I am paying the same price. Even if I am using 90% of the capacity, I am almost paying the same price in terms of compute. So only Aurora supports serverless, not other services support serverless as of now. All right. Now, let me draw this. That will be easy for you to follow. Here we have a VPC, and now I'm just using some subnet here. Consider it is private subnet, and I could deploy my Amazon RDS. So what this RDS will do is will be creating an endpoint for me. Right. So it is going to be creating an endpoint for me. So this is my Amazon RDS endpoint, basically a connection string or DNS name for my database server, and I would be connecting to that from my application. I would establish a ODBC or JDBC connection to talk to my database here. Once this is done, I could just keep it like that. But if I feel no, I need high availability, that time I would enable the multi-AZ feature on this. When I enable multi-AZ, what would happen? It would go ahead and create a copy of my database as a standby in some another availability zone. So it will pick up a subnet in different availability zone like it is an availability zone 2 and will create a standby database instance, and then there would be data replication happening on that. This is a synchronous replication. What does it mean? Let's say you say write A, B, C, D. So A, B, C, D will be returned here. A, B, C, D will be returned here at the same time, and then only we will say yes, done, your data is available. So synchronous replication copies data in both the databases, primary and standby, and then only acknowledges. So that's what we are seeing here. Yes, we will be getting acknowledgement only of this. This standby database is just a standby. It is not serving active traffic, it is just waiting for failover. It is like a spare wheel in your car. No, you do not drive on 5 wheels, you drive on 4 wheels. The spare wheel is just sitting and you would only use it if something fails. Same thing here. Standby will only become active when your primary database actually fails. So if it fails, automatically detection would happen. My service would detect that endpoint has failed, and then you would be having a standby picking it up automatically. You do not have to manually do anything on that. Yeah, it's kind of active passive. I agree on that. A question from Stockholm student: is database server and database instance same name? I would say yes. See, database server is a common word in on-prem world. In AWS world, we call it database instance, but actually it is a virtual server or a physical server which accept my database connection, which accept the request to connect and then allows me to create a database. So instance and server, they are similar stuff, just the naming convention, nothing beyond it. Right now. What I could also do if I have a lot of read requests coming up, these databases RDS support something called a relay read replicas. So I could go ahead and create a read replica. A read replica can be hosted into the same region of my choice. Like here, I have a subnet 1003 and I hosted a read replica one there. And if I need, even I could have hosted a read replica across region. So this is my region B, and then this read replica can be displayed there also. Should not be a problem, right? Read replica can be having data replicated by asynchronous fashion, which means it will be having little bit of delay before your data gets copied to RDS here. So read replica will be falling behind. They are not synchronous, they are asynchronous. So I write A, B, C, D. It may take A to come here, then will come B, then come C, and then come D. It may take little time for them, maybe few millisecond, maybe minute, but there would be little bit of lag between these primary and read replica. But the good point about read replica is that read replica get their endpoints. So I could just have my applications which require a lot of read, like my dashboarding application or my reporting application, and these application can go to read replica and read data from there. Shouldn't be a problem at all. You could decide to create it. And if I have a second read replica, it can also have a different read replica endpoint. Shouldn't be a problem at all right. I hope everyone is following along, and let me now ask some questions. My question: my primary DB instance is a, let's say it's a D dot extra large. Just give an example, just a random name. Let's say D2 dot extra large. Right. Now question is, can my standby of a different instance type? And can my read replica be of different type and size? So let's make it simple. This is, let's say, 4 CPU. So can I have standby with 2 CPU? Can I have read replica with 2 CPU? What do you think? Is it possible? Can we have this? Okay, let me now ask one by one. First question: can my standby be different size? Can my standby be different? That is true that you are saying that, okay, yes, they cannot be different. So they have to be same. Whatever is here, it is exact replica. So it would be requiring exact same thing. So that is true. Everyone is clear with that. No problem on that. Now, second question. Can my primary and read replica of different size? Primary is of, let's say, 4 CPU and read replica is having 2 CPU. Can I do that? All right. Amrinder is saying no. How about others? Answer for that is yes. Right? So answer for this particular situation is yes. You do not need to have the exact same size for your read replica, but we recommended is that should keep same size, but not always. Maybe I'm just having a small report running from it. Why I would need that much of CPU? But if this replica here is having 16 CPU and this one has 2 CPU, then obviously it would increase the lag because they will not be able to cope up with the performance. So it will still be delivering you the result, but it would increase the lag. But technically, yes, it is possible. You could go ahead and create an architecture like this. Should not be a problem at all. So I hope this thing is clear. So we could have different things. So that is good. We can use this commercial databases or open source databases. So then comes a request, why then AWS created Aurora? If this SQL databases exist, if Oracle was there, what is the need to create Aurora database? Let's talk about it. Commercial databases like Oracle MySQL Server, they would have feature, performance, and cost provided to you. They would be giving you a lot of feature. They would have a lot of cost also associated with them. So you may be paying a lot of money on that. Then we have open source databases, which is MySQL, MariaDB, PostgreSQL, which are having feature and performance not as compared to commercial, but the cost is low. So either I am compromising on the cost or I am compromising on the feature or performance. So that was obviously a gap there. Users have to select one or the other. So that's why Amazon has come up with Aurora database, which is feature and performance rich and on the lower cost of your application. So that is what Amazon Aurora is. I'll talk more on that. I have a question here from Babita. Can we replace standby with a read replica? No, No, you cannot replace a standby with a read replica. So standby, if it fails, another standby would be automatically created. It will be taken care by the system. Let me go back to the design we had. So let's say due to whatever reason, this AZ2 completely goes down, which means my standby will also go down. What AWS will do? AWS will find out another AZ3, and probably you would have a subnet there also. So it would start creating a standby there. So that can't be replaced by a read replica because they are a different way of working and they operate differently. So that won't happen. But in case, let's say, if region A itself goes down, your subnets are down, your VPC is down, and everything in region A is down. If I have this read replica, I could promote it. So that promotion is possible. You could promote it, but you have to do this manually. And your application is still talking to the read write endpoint. You may have to modify that so that it would start talking to your read only endpoint, which is now read write. So this promotion can happen and read replica can become primary, and then it will be able to serve traffic, but you would need to update your application because your application is not aware about existence of that particular endpoint. So just be aware about it. But yes, you could promote it. Good. So Aurora is there. We can use it, and Aurora has different flavors. Aurora comes with single master, multi-master. There is a global database. There is a serverless version V2 and V1, and you could utilize these things. So Amazon tried to address the problem of feature and performance on a lower cost, and then it is a database which is designed with cloud native mindset. So here, what Aurora is doing, Aurora is trying to create separate compute and separate storage. Traditional databases cannot scale that much because their compute and storage is packaged into one single unit. What Aurora is doing, Aurora is keeping storage layer separate. So all your log commits and all your data is kept separate. That is what refer as Aurora storage layer. And storage layer is basically a volume of clusters, and your data is stored across six copies in three availability zone. So we would have six-way replication across three AZs. There would be a lot of copies of your data would be maintained on that. That would give you the piece of durability. That's how it will work. So it is compatible with MySQL and PostgreSQL. You could just come in and replace your MySQL and Postgres with Aurora, and it should work. Drop-in compatibility, as we call it. It stores six-way replication across three AZs, and you have up to 15 read replica with replica lag under 10 milliseconds. So again, sometime in your questions in exam, they would be very specific about I don't want my read replica to have lot of lag, what my options are. So maybe Aurora read replica would be a better option, and there is automatic monitoring and failover happening on that. It will be automatically done by the service itself. So I hope Aurora is clear. I'll talk a little bit more on Aurora, and then we will go to the hands-on options. Now, when you are creating a Aurora cluster, so we create a cluster, and in a cluster we would have a node. So if it is only one node, that node is both read and write copy, right? It will accept read, it will accept write. So what is going to happen here, that we would get two endpoint created, right? So what we will have two endpoint. There would be a cluster endpoint which will accept read write, and I would have a read only endpoint. Currently both of them are pointing to only one copy because only one node exists, right? So that is what my single node Aurora cluster would look like. Second, we have a Aurora cluster with two instances. So out of that, one will become read write, another will become read only, and now my cluster endpoint, which is accepting read write, will point to read write copy, and read only will point to this endpoint here. So that's how it will work, right? On the other hand, if I say I want to have multiple Aurora instances, so that is good. What you could do now, you could have read only instance 1, read only instance 2, read only instance 3, and you do not have to manually talk to each of them. You would still have one endpoint for read only, and it would perform load balancing for you. So you send a request that, hey, I want to have something done, and this endpoint will say, okay, let me get it done by node number 1. Second request, node number 2, you will work. So third request, node number 3, you will work. So this will perform load balancing automatically. So you as an application owner just talk to this, and it will identify who is the optimal way to deliver the data, and it will only forward request to all those node behind the scene. So this automatic load balancing is happening behind the scene. Now this confuses people. Let's say you run a SQL query and it requires access of, let's say, 6,000 records. It doesn't mean that you would have 2000 served by this, 2000 served by this, 2000 served by this. No, we are not distributing your query. What we are distributing, let's say query number once comes and it requires 6,000 record, query 2 comes, it requires 100 record, query 3 comes, it requires 500 record. So we will forward queries to these nodes. They would still work on their own to serve 6,000, to serve 100, and to serve 500 data point which you have asked about. So that is how your auto scaling would be working. It is auto scaling of the request, not of the query. So just be aware about that factor. So read-only endpoint are scalable and you can keep on adding more node here and you don't have to change anything. You would still be having one read-only endpoint. And in cases, if you want, these also have their own endpoint. So you could directly talk to these databases, but most of the time I would talk by a group endpoint rather than individual instance endpoint. So that is what Amazon Aurora as a service is. All right, so I'll stop here. I hope everyone is clear. I will include the service summary card so you would have a better understanding. And I would also include it for Amazon Aurora serverless so you would have a better idea on how all these things work together. Thanks, Michelle, for answering the question. So yes, that's how we would be scaling. Auto scaling will be done by that. So you scale horizontally and vertically on RDS. However, the horizontal scaling is purely for read operation, and you can scale vertically for write instances. That is true. There is an option on Aurora Multimaster, both are active. So is this cause the endpoint common or distance? That would be different endpoint. So it would be sharing the load Parna in that case. So in that multi-master model, what would happen that there would be one endpoint for read write, but then it would do balancing for you behind the scene like it was a read-only endpoint doing, and it will take care of failover also. Automatic failover will also happen in that multi-master fashion for you. So yes, both will be accepting through a common endpoint. They both would accept read write request, and then they would also do failover if there is a problem on that case. So that is what would be happening behind the scene. Multi-master is little more complicated than what I explained. So maybe when we get time, we will talk more on that, because again, there are a lot of logistics information, lot of limitations on multi-master, but yes, it is also a good option available. All right, good. Thank you, everyone. I hope you have enjoyed the 1 hour, 90 minutes or 95 minutes of your discussion. And now I would add Prasad to the link so that he can come and share his details here. And keep your questions coming. And Abhijit joined us for a while and then he had to drop off. But yeah, he is supporting us from backend, helping us. Michelle is also helping a lot with all the stuff. And obviously, Prasad is there. So let me now add Prasad to stream and he would then take over. Thank you, everyone. I will be here to answer any questions if you need me. Thanks.